All right, hi guys. Today's notes should be short and sweet, and I recommend for these notes that you are using Desmos, okay? You can download an app to an Android or to an iPhone device, and then they also have a website, www.desmos.com. For following along and for completing your target, please use Desmos. The Calculate 84, it doesn't have like the full graphing capacity that your calculator does, but Desmos does. So, our notes today are going to be talking about how to solve a system of equations. So we all know something like this from Algebra 1. We're familiar with that. We could do it by hand because we're in Algebra 2 now, and we know how to add 12 to both sides, and we know how to divide both sides by 5, and we know that x is equal to 3. But today I want to show you guys a little graphing hack that can actually solve that equation for you and then also help you solve more complicated problems like the one below. So go ahead, get your Desmos app ready. We are looking at 5x minus 12 equals 3. So I open Desmos. We are going to do what I call y1, y2, second trace intersect. Okay, you don't use those keys on Desmos because that's for the regular calculator, but I just wanted to say it once so that in case we ever do get in person again and you guys are using calculators, that you know the keystrokes on the calculator are second trace intersect. So the first thing that I'm going to do, my equation was 5x minus 12 equals 3. I'm just going to graph each half on their own line. So I'm going to do y equals 5x minus 12. And then I'm going to do y equals 3 on its own line. So I do the left half on its own line, the right half on its own line, and then wherever they intersect is my answer. And as you can see, x equals 3. Whenever you do this on Desmos, you only want to look at the x coordinate. So I could do that really quickly. At 5x minus 12 on one line, 3 on the other line, and then my answer is right there at positive 3. So again, you guys could probably have done that by hand faster than we were able to graph it, but for equations like this guy, negative absolute value of x minus 2 equals negative 1/2 of x minus 2. If you're looking at that and you couldn't solve that by hand algebraically, that's where solving by graphing comes in handy. I am just going to graph this on one line, this on its own line, and wherever those two lines intersect is my solution. So back to Desmos. I am going to do negative absolute value of x minus 2. And then on the other line, I'm going to do negative, I think I'll just do 1 divided by, yeah, there we go. Negative 1 divided by 2, x minus 2. And so as we can see, these two graphs intersect at 2 different locations. They intersect here at the point 0, 2. So the x coordinate, the first part, is the only thing I care about. Okay? I only care about the first number in the pair. So I care about 0 and I care about 8. And that's it. That's my whole solution. So instead of doing all that algebra to solve, I know my two solutions, x equals 0 and x equals 8. You could list it if you wanted. You could do 0, comma, 8 if you wanted to. It's all the same. So now we're going to talk about using our graph to solve inequalities. All right? So we know inequalities are like 6 is greater than 4. We know that. But now we're going to do equations. So I want to know if I have an equation x squared, I want to know where on the graph is it bigger than 2. Okay? Or if I have the equation 4x minus 3, I want to know where on the graph that line is less than 5. I'm going to use a graph to shade in those possibilities, okay? So like if I have my line, which is 4x minus 3, and I want to know everywhere that it's less than 5, well, that's everywhere underneath the line that is less than 5. The good news is that you guys have a calculator to do this, so you don't have to have too much understanding of the operationals of it. You just have to be able to utilize the properties on the calculator. So your example in your book is, it is x squared plus 6x plus 5. I should write this down. You should be looking at it in your book though. X squared plus 6x plus 5 is greater than or equal to 0. All you have to do is put a y in the middle, okay? So what that looks like is I'm going to have the exact same equation, and I'm going to stick a y in the middle. Whatever this sign is, I'm going to put here and here. So y equal, or x squared plus 6x plus 5 is greater than y, which is greater than 0. And then when I plug that into my calculator, it will do the rest. So I would say I have x squared plus 6x plus 5 is greater than or equal to y, which is greater than or equal to 0. And so I can see that that shaded area is everywhere that my graph is greater than 0. And so that's all you can do with an inequality, is just match the shaded graph, okay? So you might get a question on your test that says to match it with the correctly shaded graph. So you might have a graph that's shaded like this, and you wouldn't choose that. You might have a graph that's shaded like this, and you wouldn't choose that. You might have a graph that's shaded like this, and you wouldn't choose that. You would find the graph that matches ours, which is shaded only from here to there. So that is your inequality. Your next example is two linear. So that would be x plus 3 is greater than 7 minus 3x. Again, you're just going to stick a y in the middle. So x plus 3 is greater than y is greater than 7x minus 3. And then you can just type that into Desmos. So I get x plus 3 is greater than y is greater than 7 minus 3x. And that's my solution. Is right there, the shading between those two lines. What it fails to show you is where the lines continue. Oh, sorry. So I have a hiccup, sorry. Your graph actually has two lines that look like this. It just chops off the end of it because all we need is the part that's shaded from there to there. And that's all inequalities are. So if you're solving for a system, do y1, y2, and then find their intersection and look at the x coordinate only. And then if you're doing inequalities, just put a y in the middle. And that's all.